software crafter was like, so like the team was super nice and allowed me to do this remote. So basically today we're going to talk a bit about data engineering, about how you build your BI infrastructure from scratch. And I will use like a use case, so we have like something to talk about. And obviously I want to say thank you to all of these companies that are back in this conference, because it's always like, thanks to the support, we can make cool things like this. So a bit of the agenda for today, so you know what we're doing. So first of all, I'm going to introduce myself a bit more, in general, because I haven't even told you my name. I'm going to talk a quick overview about data disciplines, data engineering, and we will talk about the use case at Hotjar, how we build this data infrastructure here, and then of course lessons learned and how can anyone in any company can make things better regarding data, and then we can do a Q&A or debate and talk a bit more about this topic. So yeah, basically who I am, I'm Estefani Rabada. I'm the data engineering lead at Hotjar. I joined Hotjar in August 2019. So I've been here for 2 years and a bit more. But I've been working in data for the past like 7-ish years. And in this time, I realized that I know like 5% tops of what you can know about the data world, which is huge. And it's one of the things why I like it. And the reason why I'm doing this presentation is basically because I think that engineering is a fairly new field. And a lot of companies start, building their products, building their ideas, and they think about the data disciplines. I don't want to say way too late, but a bit later than it would be better to do. And I think it's important for everyone to be more data aware and basically to share my lessons learned, because if I knew this when before, obviously I would change a lot of things. So yeah, basically I'm going to start with the quick overview that I told you about to put a bit of context. The data disciplines are mainly 3. The first one is data engineering, which is what I am and what I do. And what we do is provide clean and actionable data and provide software, code, and infrastructure. The engineer is the same as any software engineer, but the same as front end is focused on front end, back end, and back end. Data in data is not not much more to say about this. And we work with data analysts, and they basically work by providing insights. They go to the clean data that they have, they deep dive into it, and then get the insights that they need. And we have data scientists that also provide insights. It's not like a copy-paste mistake. They actually, both of them provide insights. It's just the way they do it and what kind of insights they provide is the difference between them. So data analysts are a bit more focused on analytical data, on current status, bit of the past. They usually work with SQL reporting tools. That's like their environment. And data scientists are a bit more focused in what we have now, the future, predictions and building models is a bit of different. They use Python or R. Like it's a bit of different sets and data sets, but both of them basically work by providing insights to the company and to the customers of the company. And a bit more of the engineering, we have 3 fields that we work on. The first one is batching, which is basically what we'll be talking a bit more later. This is ETLs, orchestration, and data warehouses. This is usually used to build reporting and basically help people to understand the data in like batching process. It can be daily, it can be hourly, depends on the use case. Then we have the second small part of the engineering, which is streaming. This is more oriented to real-time ingestion, event-driven systems, communication between microservices, anything related, how you send information, how you receive information, how you deal with the schema changes in real time. And for example, different use cases that you can have can be fraud detection, like all of these things that are like really time constrained that you really need to have them in time. You usually will use streaming. This is again another like huge field that we could talk for hours. And the last one, I think, is the one that has the most buzzwords, which is machine learning. Machine learning is a small part of AI, intelligence, like artificial intelligence. And machine learning engineers work very close with data science. And between both disciplines, what they do is they build and productionalize models that work in production. The thing with machine learning is also like a huge topic, and the I don't want to say the problem, but the bit of like an issue with it is like people think that you can get a data set, you get a library that has a model, you run it, it works fine, everyone is happy, and that's it. Spoiler, no, this is not how it works. You have a lot of things to take into account. You need to know how you're going to productionalize this. You have to know how the model is going to keep learning in the future. You have to make sure that this is going to work fine. And in all of my experience, 90% of the projects that fail in machine learning has been because of bad productionalization of the model. So this is very important to understand, like, it's not as easy as it looks. And it will also take us like a lot of hours. But yeah, as I mentioned before, we're going to focus a bit more today on batching. Okay. So when I joined Hotjar, I was the first engineer who joined. The company was there since July 2014, I think, but it was like 5 years old. And I was the first engineer who joined after 5 years. I joined in August, another data analyst joined around September, and then we were the data team, both of us, in a company with like 100 people. And obviously when you need to build an infrastructure about anything, you need to know what are you going to do with it. So we started asking around what they wanted in marketing, the C-level, product managers, like everyone, what they wanted out from all of this BI infrastructure. And what we got is like, we want reporting tools to track MRR, LTV, churn, all of the things that you basically need to know how your company is doing. They had current solutions at the moment when we joined, but they were like black boxes. They had things that were managing their subscriptions, but it would say your MRR is 3, but you don't know why, you don't know how, you don't know anything about that number, so you can't actually do much with it. And they weren't happy with that. The other thing they wanted to know about is about how the product was used. Hotjar, for example, since we're using this example, it has heat maps, it has recordings, it has feedback, it has a lot of different tools that our customers can use. And obviously, it was important to know which type of customer was using what, how often, and basically everything. Basically, they wanted all the data. They wanted to know everything that they wanted, which was a lot. And as everyone who uses a company, something like having like a playground like this, where you have to build everything, and there is not that much built in that area because you're the first one, is good. It's very nice, to be honest, but it's also a bit challenging because you have all of the power to make great things and to mess it up. So obviously it's like a bit of like a trade-off. And we started, like, in this case, me, because I was the only engineer, I started researching what we have at the moment. So we have like this huge monolith that was writing events into something called Segment. Segment is a tool. What basically does is like you send events to Segment, and then Segment sends it to destinations, any destinations that you may have. And what they decided before I joined was to have all of these being sent to a data lake built on top of Redshift. The first issue with this is like data lakes should be stored in an organized storage. Like having a data lake stored in something like a database doesn't make sense because is an structure, is some type, you can't match that. But this was decided before I joined. It was a bit hard to change it. So we keep it like it is, and we started building on top of that with a mindset of changing it in the future. So this is when we started to building the data infrastructure as we wanted. Okay, so the first thing that we wanted to have is a data warehouse. We created another Redshift cluster. We decided which type of like data modeling we wanted to use. Data modeling is another huge topic to talk about, but to make it short, basically we decided to go for like a star schema modeling with dimensions and facts. And the idea was to have all of the unstructured things that we had on the data lake, have them in the data warehouse in a structured way, model way, so everyone could act on it. Okay, so how you do that? So as I mentioned before, this is about batching, so you do it with batches. So we started using something called Apache Spark being run on top of EMR. Okay, so Apache Spark, and if you hear anything about data, you will hear a lot about Apache. They are like this huge organization that stores tons of different repositories that are mainly data related. One of them is Apache Spark, which helps you deal with a lot of data. It helps you transform it and do a lot of different things with it. The problem with the Spark is like having a Spark cluster running for like a long time is very expensive. And obviously you need to make sure that you are not wasting a lot of money in something that you just run daily in this case. So unless you have real-time case scenarios, it's not useful to have a cluster running all the time. So we use something called EMR. That is something that AWS provides. Something that I forgot to mention is that Hotjar is very AWS coupled. So everything that we used was in AWS, but this can be used in Google Cloud, like in any other cloud storage or like cloud system. And EMR clusters are elastic map reduce clusters. What this does is you can create a cluster, you can use it, and you can kill it, and you only pay for the time that cluster is running, which makes things very cheap. So you have these processes that were like extracting the data from the data lake. They were transforming it, and they were then saving it into the data warehouse, and we need to run that at some point. So we use Apache Airflow. This is another Apache software. This is an orchestration tool. What it helps you is like you can schedule any type of job and in any way. Like you can choose hourly, daily, like whatever works for you, Airflow will do it. And we have that running in a Kubernetes cluster. Okay, so this was the end goal that we have. We wanted a data warehouse. We needed to populate it with all of the events that we were getting in the data lake, and we needed to do it on a daily basis properly. And obviously, once everything is in the data warehouse, what you do with it. And this is when the analysts came and they built Tableau on top of it. Tableau is a reporting solution. Basically, what you do with it is that you can load any data set that you want from any data warehouse, and then you can work with it and create reports and different stuff. So this is the infrastructure that we decided to do for Hotjar, in the sense of like in the batching area of the engineering things, which was a lot for one person. Once we decided to have the data warehouse, another very important thing to keep in mind is data quality. Something that I've learned along these years is that when you can have any application, and if you have a button and that button works, and then suddenly one day it doesn't work, and then you fix it, and then it works again, the customer will be happy, people will trust that button again, and that will be fine. But with data, it's not the same. If someone gets a data set, something is wrong, you lose trust. Like they lose trust on the data, they lose trust on you, and gaining that trust back is very, very, like I can tell you, super hard. So this is why every time you build any type of data infrastructure, you really need to think about this side of things, okay? So data quality has a lot of different dimensions. They usually have 6, 7, depends on where you read. I'm going to tell you the ones that I usually use in case it's useful for you. So basically you have accuracy, which is, they are self-explanatory, which is basically how accurate is your data with the real world. You have completeness, which is again, how complete is your data. You have consistency, how consistent is in your organization. Timeliness, is the data available when it needs to be? That's timeliness. You have validity. All of the fields have the validation that they should have, like emails have the proper form, like, to make sure that the fields that you have are properly validated. And uniqueness, you don't have duplicates on it. This, to work with data quality, there is no like a rule that you can apply everywhere. It depends a lot in the company that you are, the type of data that you're working with. So the most important thing that you have to do once you decided that you have this data warehouse properly populated is make sure that you order these dimensions in the order that are most important to you and start tackling them and make sure that you can provide that. In our case, for example, accuracy was one of the most important ones. Basically, what we wanted it was to let people know, like, this is, for example, let's think about a user dimension. You have there like the history of your users. Like, this is accurate up to 99.9%, just to make sure that if someone saw something that was a bit off, we could tell them like, oh, here is almost like perfect because of this and this, and then you don't lose that trust that people can lose with data. And I forgot to put it here, but there's like a tool that I really like, which is called Great Expectations, like the book. And this tool is very cool. It has like a very nice implementation with Airflow, and it allows you to track all of these dimensions, new things that you want to track. Like, it's very, very useful. So if you're interested, like, check it out because it's very nice, and it's open source, of course. So yeah, basically this was like the end of the building of the infrastructure. And when we were halfway, so that's not halfway, but yeah, most of like at the end, there are like a lot of things that I realized that I should have done better, that's why it's lessons learned, because if I'm in the same situation in the future, obviously I will try to not make the same mistakes again. So the first one is always question the current state. I'm saying this because, as I told you, like, we had like this monolith. This was sending events to segment, and this was saving things into the data lake. And I checked a bit the data, and it looked good. The problem is not all of the endpoints of that microservices were sending events to that segment tool. That meant that we missed some data, and we didn't realize until later. So that's why I always say that it's super important that even if it looks okay, spend your time checking things, because with data, if you mess up at the beginning, trying to back it up, it takes time. And the more time you spend at the beginning, the less you spend later trying to fix the stuff. The second one, and I think this can be used in data engineering and in general, is good to follow that North Star architecture that I showed you, but don't run towards that. Like, the biggest mistake that I made was like build that from scratch by myself. And it was when I achieved it, it was good, but the journey was very harsh and it wasn't worth it, because you can make things better if you iterate over stuff and if you have like a smaller goals to tackle. And I think this is general. This is not just data engineering. The third one is also a bit general. Don't be afraid of finding new ways to get the same solution. With this, I mean, and it's also related to the fourth one. When I mentioned that we wanted a data warehouse, the only way to get a data warehouse, there is not an only way to get a data warehouse. Like, that ETL processing is one of them, but you can have other solutions. So if you have the time, it's better that you learn, like, understand everything that is new in that area before starting like building things. For example, in this case, I find out after that there is something called Lakehouse. This is a very easy way to build kind of like a data warehouse structure on top of a data lake without having ETLs running. That would make my life way easier if I knew that back then. So this is why it's super important to, find new ways to spend your time learning, and especially, I mean, in software engineering in general, but data engineering grows like every week. Every week that I read posts and stuff, there is something new, something nice, something shinier, and it's always important to be, on top of that, because it basically makes your life easier. And yeah, the fourth one is the same. Be mindful of the time and people power you have when you're planning. Even if you are yourself, in my case, or you have like a bigger team, it took me 6 months to realize that I needed more people in the team. So imagine 6 months, that's a lot of time that I could have started hiring sooner, and we can have like a proper team to tackle this. So this is like very, very important when you are building something from scratch. Don't underestimate work, and make sure that you have the people power and be mindful of time. And the extra one, and this is very data engineering related, is not introducing streaming soon enough. So when I mentioned the 3 areas of the engineering, I mentioned batch, streaming, and machine learning. The thing with the streaming is that sometimes it's harder to maintain, in the sense of like, if a batch processing fails, you see that the next morning, you fix it, you run it, that's good. If streaming fails, you need to be on top of that. So that's why it's always people are a bit scared of introducing that sooner. The thing in this use case that I show you is that if I question the current state and I realize the issues that it had, having something streaming wise will make my life way easier. So for example, there is something in streaming called CDC, which is change data capture, when you can basically it's like the observator pattern. You can be just looking at a database and see when something is created, updated, or deleted, and that gets transformed into events. And you can save that into a data lake, S3, or whenever you want. If I were to introduce streaming sooner and make sure that I fixed all of those issues that the current state had, that would have made like a huge change in like all of the post work and everything in general. So yeah, this is not introducing streaming is the same as like, don't be afraid of like go for like something a bit more complicated, because at the end probably will make your life a bit easier. And then as a general, I think that all of the companies are very invested in data lately, and all of them want to be like data driven, data mindset, and all of that buzzwords that people love to use. But I do think that anyone in every company can make a difference. Okay, so I put like a bit of like things that I've learned in the past to share with you in case it helps. So for fellow software engineers, backend and frontend, first of all, like, think always about how that operational data can be used in the future. Like if you create a user, if you update a user, like think what can happen with a user, think if it's important to store a bit more of details or less. It's easy in the future to delete stuff. It's impossible to create data from the past that you don't have. So that's a good one. The second one is something that I was damn shocked to see every time that I see it in a lot of databases. Always use timestamps. Like you can't do anything with an event that happened if you don't know when that happened. It can be about something is created, when something is updated, anything. If you don't know when that happened, you can't use that for anything. It's the same as not having nothing. It's the same as having nothing in that sense. And the third one is save historical data unless you have a good reason not to. So nowadays, all of the relational database have triggers, have everything. So it's very easy to set up a trigger until the database, every time you delete something in a table, save a new row here. It won't be harder for the code, and you will have that historical data that will help your company in the future for sure. And the second part is product people. I don't know if we have product people in the room, but it's always very important to think about the data. So one thing that happens a lot with product managers and product designers is that they like, for example, machine learning features. They love that. They love to have those new features in the product. But one of the things that is super important for product people to know is like the output of a data model is as good as the input that you have. So unless you prepare for that, the output that you're going to have is not going to be that good. So it's very important for you to think like how current data can be used in the future. And basically, the more product usage information you have, the easier it will be for you to decide things in the future. And the third one is for the infrastructure engineers in the room, if we have some. If you can keep daily snapshots of the databases, that'll be great. Nowadays, the storage is super cheap, so it will be very good to have it. And the second one will be try to provide with cheap data storage. that is easily accessible to the software engineers on your company. Like you have AWS S3 that is very cheap, or cloud storage in Google. Like you have a lot of different solutions that will make your life very, very easy to set up, and it will help your software engineers to be more mindful about data and to use it more. So yeah, that was basically everything. I know that it was like a very big overview. I didn't want to get into too much details because, you know, I think it's more important to go details that people are interested in, if there is someone interested in anything. And yeah, we can go for Q&A, or if you want to debate something, that would be awesome.
All right, Gerardo, thank you for your presentation. I really love all the details and the values that you share with us. I would like to ask you, who is responsible for keeping the models in sync? Imagine that you have a team, and this thing is putting some data into the data lake, and then at some point they decided to make some change in the model of the data. And who is responsible for providing those changes to the data warehouse?
So yeah, basically, when someone changes in the data pipeline, is a mix of ownership. First of all, the team that owns basically, let's say, the producing of the message, they have to own that part of the changes, and obviously the data engineering team needs to own that second part. So anything that as soon as something is already sent to, like, let's say, I don't know, 80, I don't know, any message pass, from that onwards, that's the data engineering team. But obviously the product team needs to be aware of like any changes when producing messages. So I would say it's a shared ownership. There is usually shared ownership in a company.
You talked before about machine learning engineering, and 99% of the failure of these kind of models were because of the, let's say, you talk about the communication between the data engineers and the data science. I don't know if you could give us some examples about how can this lead to these failures of the models, because maybe this communication you talk about the importance that you keep a good performance of the model between the data engineering and the data science.
So yeah, basically, when I mentioned the machine learning projects failing, I can give you like the one example that I had in my previous company, which is we had like this forecasting project that was working amazingly good in the data scientist laptop, and this failed because how that project was structured, the data science work on the model, then it grabbed the model, sent it to a data engineer, and that person needed to productionalize the model. The problem with this is like when you productionalize a machine learning model, it needs to keep learning. So you need to have a data set to train it, you need to have a data set to test it, but then you need to make sure that you keep making that model learn. So how to solve this and how I've seen things succeed is like if the machine learning engineer and if the data science person start working from the beginning together, that's what usually makes these projects a success. Because in that case, you have two people knowing what they're doing, deciding together this data set for training, this data set for testing, and how often are you going to, retrain the model? Like if you have two people thinking about that, you have the end-to-end cover, and then you make sure that all of that works fine. So what I mentioned, the importance of the machine learning and how this fails is basically because, as I mentioned, this discipline is seen as, you do something in your laptop and it works and it's good to go, which is what never happens. And then the sooner a machine learning engineer works with data science, the better, and the easiest is that project succeeds. Okay, so that's it. Thanks a lot, everyone, for joining this call. I really hope it wasn't like too boring and you enjoyed it. Feel free to reach out to me on LinkedIn. Again, super sorry that I'm not there with you to go for lunch now. And that's it. Hope you enjoyed the weekend, and super nice being able to assist even if it was remote. Thanks a lot, everyone.